All right, so we're dealing with another Le Chatelier's principle problem, as they share with us right here. And I want to note here this ugly word, perturbation, essentially is meaning that we're stressing out a system that's already at equilibrium. So one of the things we need to be aware of here is that whenever we mess with temperature and an equilibrium, it impacts wherever we have heat in our equation. So one of the biggest things we look for in problems like this whenever we're changing temperature is we're looking at what type of reaction we're dealing with. And this is an endothermic reaction. Now, why is that a big deal? Well, if we have an endothermic reaction, what that means is that we are dealing with heat being on the reactant side. That's the way to think of it. So anytime you have a change in H for a reaction that is a positive value, it's the same as having heat over here. Now, why does that matter? Because if we mess with the temperature and we raise it, we're raising wherever heat is. And again, whenever you mess with something on one side of the equation, the reaction is going to try and even it out. So let's take a look at the options they're giving us here. And the first one they're doing is they want to raise the temperature. So if we raise the temperature, what we're thinking we're actually going to do is we're going to increase where heat is. And if we're increasing heat to get rid of that stress, the reaction is going to shift away from that. So the end result is going to be you're going to end up with more of this and more of this, and you're going to end up with less of these two things because the reaction is going across from us. So if we take a look at the question, they're saying, what is the pressure of H2O? And remember, if we raise the temperature, right, we're raising the heat essentially, and we're sliding across. So what's going to happen to our H2O? Well, our H2O is going to end up going down. So it's going to go down. And we already kind of answered this question, because as we go up, the reaction is going to go, as the temperature goes up, the reaction is going to go over to the other side. So our answer over here is going to be to the right. Now, what if we lower the temperature? Again, now we're dealing with almost exactly the opposite scenario here, because we have heat on our reactant side. As we lower it, the reaction is going to shift this way to counteract the change. And when it does that, what's going to happen to our O2? Well, since our O2 is on this side over here, and we are shifting away from it, the O2 level is going to go down. So, again, we kind of answer both the questions simultaneously, but the pressure of the O2 is going to go down. And which way we're going to shift? We're going to shift to the left. And up here, when we raise the temperature, we're going to shift to the right. Hopefully this has been helpful.